Welcome to our 12.4 through 12.6 notes. We're going to continue talking about three-dimensional figures in this lesson. Last lesson we talked about surface area, and this lesson we're going to be talking about volume. So before we do some volume problems, I just want to talk about the type of unit that we use when we are doing a volume problem. The type of unit we use is a cubic unit. And I just wanted to show you one illustration to show you what this really means. So imagine you have an empty box that measures 3 inches by 4 inches by 2 inches, and you're wondering how many of these 1 inch by 1 inch by 1 inch cubes it would take to fill up this box. Well, if you started placing cubes in the box, eventually you would have this setup where you have 3 cubes by 4 cubes by 2 cubes. Well, if we multiply 3 times 4 times 2, we get 24. So this 24 cubic inches means that there are 24 of these 1 inch by 1 inch cubes it would take to fill up this space. So be really careful with your units when you're doing a volume problem. Make sure that you always put your answer in cubic units, because a cubic inch is different than a square inch, which is different than a regular inch. All right, so let's just take a quick look at some formulas. I don't think any of these are new. I think you should have seen all of these before. When we're finding the volume of a prism or a cylinder, those are those shapes that have two bases, we simply take the area of the base and multiply it by the height. Remember, the height is the distance from one base to another. If we're talking about cylinders, we can be a little more specific in this formula. Since the base of a cylinder is always a circle, instead of saying capital B times H, we can say pi r squared times H, because capital B, which is the area of a circle. All right, and then for cones and pyramids, we could do an illustration where let's say we took this cylinder and this cone. They have the same height and the same base radius, okay? If I were to fill up this cone with water and pour it into this cylinder, it would fill a third of the cylinder. So in other words, the volume for a cylinder with the same height and the same base radius as a, let's see, the volume of a cone with the same base height and radius as a cylinder would be 1/3 of the cylinder. So for pyramids and cones, make sure you have that 1/3 out in front of your formula. And remember, when you're talking about a cone, that base is always a circle, so we can be more specific and say 1/3 pi r squared times H. So now let's take a look at some examples where we use these formulas. So this first example, we're taking a look at a pentagonal prism. So to find its volume, let's start with the formula for the volume of a prism. And that formula is volume equals capital B times H, where capital B is the area of the base. So let's rewrite that formula, and let's replace capital B with the formula for the area of a regular pentagon. So that would be 1/2 the apothem times the perimeter times the height of the prism. So that would be 1/2 times the apothem we're given is 3.4. Glad we didn't have to figure that out. And then the perimeter, it's a pentagon with each side that measures 5, so that's going to be 25 for the perimeter. And then the height, which is the distance from one base to another, is 8. All right, so a little bit of multiplication. Your final answer is going to be 340, and don't forget those units. This is going to be in millimeters cubed. All right, and then the next example, here we have a triangular prism. The bases are triangles, and we can see that those bases are 10 feet apart. So we're going to have to find, let me go ahead and write the formula. Volume equals capital B times H. Well, the area of a triangle, we need to take 1/2 its base times its height. So the first thing we need to do is find out what the height, and when I mean height, I'm not talking about the height of the prism now. I'm talking about the height of the base, which is a triangle. So I'm going to go ahead and label this hypotenuse as 15 feet. And so now to find this missing leg of my right triangle, if you know your Pythagorean triples, then you should know that that missing leg is 12 feet, all right? So now to find the area of the base, we're going to take 1/2 9 times 12. Just make sure you're picking two dimensions that are perpendicular to each other and call those the base and the height. So this is the area of the base, and now I need to multiply it by the height of the prism, which is the distance from one base to another. So we'll multiply that by 10 and then do the arithmetic. Our answer turns out to be 540 feet cubed. All right, and now let's find the volume for the cylinder. This 9 is pointing to this entire pink segment. So in other words, it's pointing to the 9 is the measure of the diameter of that segment. So I just want to point that out. Let's start with our formula. We're going to take the area of the base times the height. Since the base is a circle, I'm going to call the area of the base pi r squared. And then the height will be that distance from one base to another. So we're going to multiply pi times the radius. Now be careful, remember this 9 inches is the diameter, so that means my radius is half of 9 or 4.5. So that would be pi times 4.5 squared times the height of the cylinder, which is 5, okay? And then we'll multiply that out. I'm going to write my answer two ways, one in terms of pi and one not in terms of pi. So you'll just need to follow your directions. So that would be approximately equal to 317.09, I guess I'll round it to the nearest tenth. Whichever answer you use, the units will be inches cubed. Okay, so just follow directions as far as rounding and whether or not to multiply pi out or not. All right, now let's look at an example that is a little more interesting. It has a little more problem solving to it. It says a manufacturer packages its products in cardboard boxes so that they have the same length and width but different heights. If the volume of box B is 150 cubic inches greater than the volume of box A, what is the length of each box? Okay, so they have the same length. So I'm going to go ahead and label both the boxes. I'm going to label the length of both boxes L, okay? And then I just want to kind of write out a little equation to generalize this. We're told that the second box is 150 cubic inches greater than this one. So I'm going to write an equation. I'm going to write the volume of box A and add 150 to that. And if I do that, then that would be equal to the volume of box B. Because remember, the box B is 150 greater than box A. So how would we find the volume of box A? Well, we would take its length times its width times its height. So that would be, let's see, 4 times L times the height of 7 plus 150. Now let's replace the volume of B with a formula, which would be 4 times its length times its height, which is 10. And then simplifying just a bit, we'd have 28L plus 150 equals 40L. So 150 equals, let's see, 12L. I'm just going to subtract 28L from both sides. And then divide both sides by 2. And L turns out to, I'm sorry, not divide by 2. Duh. We're going to divide both sides by 12. So L turns out to be 12.5 inches is the length of each box. All right, and then this last example says we have 2 containers. It says the containers at the right are filled with popcorn. Yum. About how many times as much popcorn does the larger container hold? So what this is asking us is if we talk about the volume of box A, what would I multiply the volume of box A by to get the volume of box B? So let's just fill in the equation. The volume of box A would be the area of its base times its height. This 14.5 is the diameter, so that means our radius would be 7.25. So the volume of box A would be, let's see, the area of the base would be pi times its radius, 7.25 squared, so that's the area of the base, times the height of 18, times x, let me change the color so that's a little bit more obvious. Okay, times x is equal to the volume of box B. Well, if we want the volume of box B, we're going to take the area of its base times its height. There we go. Okay, so the area of its base would be, now remember this again is a diameter, so that means the radius is 11.4. So the volume of that second cylinder would be pi times its radius, 11.4 squared, times its height, which is 18. So we can see, to answer the question, solving this equation for x, how many times greater is the second cylinder than the first one? We just need to divide both sides by this, pi times 7.25 squared times 18. So I'm going to do that real quick. Divide both sides by pi times 7.25 squared times 18. Pi times 7.25 squared times 18. So we can see a lot is going to cancel here. The pi's will cancel, the 18s will cancel. So grab a calculator, and when we take 11.4 squared and divide it by 7.25 squared, it turns out to be about 2.5. So that means that this container will contain about 2.5 times the amount of popcorn that the smaller container will hold. Okay, so now let's find the volume of a pyramid and a volume of a cone. So remember, to find the volume of a pyramid, it's going to be 1/3 the area of the base times its height. Well, this pyramid is a rectangular pyramid, so the base is a rectangle. So capital B we'll find by taking 9.5 times 8. So we're just going to take 1/3 times the area of the base, which is 9.5 times 8. And then the height of the pyramid would be 9. So we'll multiply that by 9. Okay, do the arithmetic, and the answer turns out to be 228 centimeters cubed. All right. And then to find the cone, we're going to find its volume, we're going to take 1/3 times the area of its base. Since the base is a circle, I'm going to go ahead and write the formula of a circle. So 1/3 the area of the base times the height. So let's see. We need to know the radius, and we need to know the height. Well, we're given the height. The height of the cone is 11. To find this radius, we're going to have to do a little bit of trig here. So let me highlight. We're going to take a look at this right triangle, okay? And we're going to work with this 58-degree angle. With respect to the 58-degree angle, we know the opposite side. And then we're looking for the radius, which is the adjacent side. So since it's opposite and adjacent, that means we're going to be using the tangent function. So the tangent of a 58-degree angle equals opposite over adjacent. That would be 11 over r. So that means r equals 11 divided by tangent of 58. So grab a calculator, and that turns out to be about 6.9. All right, so back to our formula for the volume of the cone. We'll take 1/3 times pi times our radius of 6.9 squared and multiply that by the height of the cone, which is 11. Well, you know what I'd rather do? Hold on. I don't want to put a rounded answer in there. Let me erase this. Remember, our radius was 11 divided by tangent of 58. So let's put that in there instead of a rounded number. Tangent of 58. Okay, and then multiply by the height, which is 11. Okay, so now grab your calculator, and we should end up with 173.2 pi if you left it in terms of pi, or if you multiply pi, it'd be 544.2. Either way, our unit is going to be inches cubed. Okay, so the last three-dimensional object we're going to study is a sphere. Now, this definition will sound very familiar to you. The definition of a sphere would be the set of all points that are equidistant from a point called the center. Now, that definition sounds very much like the definition for a circle. The only difference is, if we were talking about a circle, we would add the phrase, the set of all points in the same plane that are equidistant from a point called the center. So if we take out the restriction of a plane, and we're talking about all the points that are in three-dimensional space that are the same distance from a point called the center, then that would carve out a sphere. All right, so let's look at two formulas, the formula for the surface area of a sphere and the surface area for the volume of a sphere. Now, this is just a really rough demonstration of how to get the surface area of a sphere. If you can imagine taking the cover off of a baseball and laying out flat, this is roughly what it would look like. And this is a bit of a stretch, but notice that it's pretty much that surface area would take up about 4 circles, okay? So the area of one circle is pi times the radius squared. So if I want to get the total surface area of a sphere, we just take 4 times the area of one circle, 4 times pi r squared, okay? The formula for the volume of a sphere, I'm just going to go ahead and give you this formula to use, but I do want to show you a YouTube video. I'll try and remember to do that in class tomorrow, that shows you how this formula is derived. If we have a sphere that has a radius of r, then we can find the volume of that sphere by taking 4/3 times pi times the radius cubed. Okay, so let's work a couple problems here. The first example says, find the surface area and volume of this sphere. So this is a sphere with a radius of 6. That's the only dimension you need to know to find both surface area and volume. So let's start with surface area. Surface area formula is 4 times pi times the radius squared. So this would be 4 times pi times 6 squared. So if we multiply that together, we're going to get, oops, that's an equal sign, sorry. We're going to get 144 pi, or if you were to multiply that out, it would be 452.2. Either way you write it, use the correct unit. Now this is surface area that we're finding, surface. So our units will be centimeters squared. All right, so that's surface area. Now to find the volume of this sphere, we're going to take 4/3 times pi times its radius cubed. So that would be 4/3 times pi times our radius is 6 to the 3rd power. Okay, simplifying that in terms of pi, it would be 288 pi, or if you multiply pi out, it would be 904.3. This time, since it's volume, our unit is going to be centimeters cubed. All right, and then the next example, we're going to find the surface area and volume of a hemisphere. So that's just half of a sphere. So to find the surface area and the volume of a hemisphere, we will just take half of these formulas, okay? So let's start with the surface area of this hemisphere. So to find the surface area of the hemisphere, we're going to take 1/2 times 4 times pi r squared, or that would just be 2 pi r squared. So 2 times pi times our radius is 2.8. So we'll multiply that out and get either 15.68 pi, or if you multiply pi out, it would be 49.2. Either way, our unit is going to be centimeters squared, okay? And then the volume of that, of this hemisphere, we're going to take 1/2 times 4/3 times pi r cubed. So that would be, I'm going to go ahead and simplify. 1/2 of 4/3 would be 4/6, which reduces to 2/3. So 2/3 times pi times 2.8 cubed. So grab a calculator, multiply it out. We'd get either 5.2 pi, or if you multiply pi out, it would be 16.4. But either way, our unit is going to be in centimeters cubed. So last but not least, let's find the volume of this sphere. Now remember, to find the volume, we take volume is 4/3 times pi times the radius cubed. So the first thing we're going to have to do is use this circumference to find the radius. Remember, circumference is found by taking 2 times pi times the radius. So if my circumference is 18 pi, I'm going to set that equal to 2 times pi times r. Divide both sides by 2 pi. And we get that our radius is equal to 9. So that's the piece of information I needed for this formula. The only dimension I need is the radius. So the volume of this sphere then is going to be 4/3 times pi times 9 cubed. And that turns out to be either 970, well, let me write that so you can actually read it, 972 pi, or if we multiply pi out, that would be 3052.1, but either way, the unit is centimeters cubed. All right, so if you have any questions over these notes, be sure and ask me in class, and I will see you then.